in this video, we're going to tackle about permutations and combinations. So first of all, we have to know what permutations and combinations is. So permutations is associated with arranging things in different ways. In combinations is only concerned with combining things. Order doesn't matter. So we always have to remember that in permutations, order does matter. But in combinations, order doesn't matter. So here, I'm going to give you an example so you will know it more about permutations and combinations. So here, I'll give three letters: letter A, letter B, and letter C. Here, in this side, we have three letters, and in the other side, I'm going to write C, B, A. So we have different values here in this side and in this side. So we're going to know in permutations we have two values because in permutations it is different. This values is different. So we're going to write P is equals to 2 because these two is different. But in combinations, these two values is just the same because as we recall what I just said recently, combinations order doesn't matter. So once this letter, like this one, once this letter A, already appeared, this one will not be considered anymore. So in combinations, it is only 1. So this is just sums up, and this is not considered anymore. And after this, I'm going to give another example so you will understand it more clearly. Wait. Oh no. Okay, so I'm going to give another set of example. 4 letters now. So letter A, letter B, letter C, and the last letter is letter D. So now we have, it's moving. So now we have 4 letters, A, B, C, D. So we're going to pick 2 letters from these 4 letters. So now the question is, how many possibilities can we make 2 letters from these 4 letters? So we're going to write down all the possible letters that we can get from these 4. So first is A, B, and then A, C, and then next is A, D, and then next is B, C, and then next is B, D, and then next is C, D. So we're going to write again, just in other way. B, B, C, D, A, B, C, and D, B, and C, D, C. Correct. Okay. So here are all the possible outcomes that we can get from these 4 letters. These are all the 2 possible outcomes that we can get from these 4 letters. In permutations, because order does matter, we will only get 12. So why 12? As we're going to count this, we can count 4, 8, 12. So there are 12 outcomes. But in combinations, I think you already know that how many outcomes is combinations. In combinations, order doesn't matter. So it means this one, A, B, and BA is already cancelled because it will only count this one. So let's all count AB, AC, and let's cancel. Where is it? Wait. Let's cancel. Oh, sorry, this one is wrong. This is AC. Just kidding. This is CA. Okay. So AC and CA is not considered anymore. And AD, we're going to count this one. AD and this one is not considered anymore. And BC, CB is not considered anymore. And BD, and then DB is not considered anymore. And then CD, and its opposite is not considered anymore. So, as you can see, combination is only 6. There are only 6 combinations in these values. So, the question is there a simpler way to get the values so that we're not going to list them all and we will get tired? Yeah, we'll get tired just to list them all and cancel. So is there a simpler way? So the answer is yes. And I'm going to show you the formula for each. So here, I'm going to show the formula for permutations. So first, the permutation N, P, R. Okay? NPR is equals to N factorial divided by N minus R minus, yes, this is the same, minus R factorial. So, how are we going to apply this formula to these values? So, how are we? Okay. So now we're going to put this in the equation. So 4P2 so equals to 4 factorial divided by 4 minus 2 factorial. Okay, so now we're going to get the factorial of 4. So we're just going to multiply all the integers until we reach 1. So 4 times 3 times 2 times 1. Okay, and then over, wait, I'm going to write it again so it will be more clear. 4 times 3 times, oh no, it's not writing. sorry, I will get another. Then 2 times 1 times 4 minus 2 is 2. So 2 factorial is 2 times 1. So, of course, we're going to cancel this because it's just the same. This and this. So, it will be cancelled out. Okay. So, these two numbers will only remain. So, 4 times 3. 4 times 3 is 12. So, as you can see here, permutations, 12. In combinations, there is another way. There's a different way of its formula. So, the formula is N. Oh no, it's not writing. N. So, NCR is equals to N factorial over N minus R factorial times R factorial. So, how are we going to apply this formula in these values? So, now we're going to apply this formula. So, we're going to write 4 factorial over 4 minus 2 factorial times 2 factorial. So, we're going to expand this. So, 4 times 3 times 2 times 1 over 4 minus 2 factorial is 2 times 1 factorial times 2 factorial is 2 times 1. So, now, 2 times 1 and 2 times 1 is just the same as 4. So, we're going to cancel this out. Cancel this. And so, these three numbers will only remain. So, 3 times 2 times 1 is equals to 6. So, as we can see, the formula really works. So, these formulas can help us to calculate maybe in real life problems so that we can solve easier. So we can solve easier for when we have real life, or we need to calculate something. We can use these formulas that are given. So that's all. Thank you.